Okay guys, welcome to this short video on a recap of the mechanics part of mechanics and materials, and also some exam info for the 2017 subject. Okay, so we're going to be mainly talking about focusing on what topics and what are going to be in the exam and what equations you are going to need to know. So first of all topics that we covered in concept are examinable. Okay, which you're probably not too excited about. That means you need to know every topic that's covered in the lecture notes, and I'm going to go through those now. Okay, so first of all we started off with definitions. Okay, and the only ones I expect you to remember are the definition of strain, which is the derivative of the displacement. Okay, in this case with respect to x, the y strain will be the derivative of the vertical displacement, for example, or the y displacement with respect to y, and the shear strain I would expect you to know is equal to this. Okay, expect you to know that. Also expect you to know the shear stress tensor, okay, which is basically the definition of stress. Okay, and I showed you that at least in 2 dimensions, the shear stress tensor looks like this, and I would expect you to know, or to be able to sketch from that, what the stress looks like on a solid element. So on a solid element you would have sigma yy, say in this direction if upward was the y direction, sigma xx, same on this direction, same here. Okay, I'd expect you to be able to draw this if for example I had numbers here, and this was positive direction, sigma xy. Okay, expect you to know the direction, which direction is positive and which direction is negative. Okay, so that was pretty much the first lecture. And then next we have, we learnt about strain energy. So I expect you to know, just dropping back to here, don't expect you to know anything else in that first lecture. Any of the other definitions, don't expect you to be able to derive this, for example, just to know what these are. Okay, then we went on to strain energy, and I would expect you to know for a uniaxial load what the strain energy is, because you're probably going to need to use that. So the strain energy density was half times sigma times the half times the stress times the strain, and the strain energy is half times the load times the displacement. Okay, expect you to know that, expect you to know the units just like in the mid-semester test. And this one is probably the most important. For bending, you need to know the strain energy is equal to 1 on 2ei integral of m squared over the length of a beam. Okay, these I expect you to know, to remember, that is. Okay, so I want to be clear about what you need to remember and what will be given to you. Anything that I don't tell you in this video, anything I don't tell you you need to know, you don't need to know, obviously, and it will be given to you if you need to use it. I'll repeat that as we go. Okay, so the next thing we went on to is using these strain energy methods, and we did virtual work. Okay, I expect you to know what that is, and you should know how to use it, but not how to derive anything. Just know how to use, up to the same level as the tutorials, to the level of the tutorial question. Okay, that's all I really need to say about that one. Next we did Castigliano's theorem. I don't expect you to know how to derive Castigliano's theorem. That was the next of the strain energy methods we used. Okay, in Castigliano's theorem, I expect you to know this equation. The derivative of the strain energy with respect to the load is equal to the displacement at the location of the load. I'll just write that quickly, where U equals displacement at the load location. Okay, very important. I also expect you to know if there is no load and you need to find the displacement at a point, you need to know the concept or how to apply phantom load. You should be able to solve a statically indeterminate problem. This was the next topic we covered. And you should be able to solve it using the two methods that I showed you. Okay, the next thing I think we did was it the next thing? Well, maybe I haven't got quite in order, but we did thermal expansion. I would expect you to know that the strain is equal to the thermal expansion coefficient times the change in temperature, which will lead to an extension of a rod, say, or uniaxial extension L for a rod, length L. Okay, I would expect you to know those things. So this is extension. Okay. And then what came next? Impact loading, I believe. So for impact loading, I would expect you to know how to use equations such as the extension is equal to the square root of the dropped height times the static extension. I would expect you to know how to use these and how to calculate the static extension, for example. So this is for a weight dropped from a height h. And of course, to calculate the impact load if you were given this equation. I don't require you to remember these equations. So not much to remember there, just know how to use them. And you should know, of course, that the impact load is determined by equating the strain energy in the solid that is being hit with either the potential energy of a mass hitting the solid or the kinetic energy if you knew the velocity of an object hitting the solid. You will find in previous exams that I've required you to be able to equate strain energy in a solid to the incoming energy of a moving object. Okay, then we went on to buckling. And this is probably the one with the most equations in it. You should be able to derive the buckling load. Right? But I would also expect that you know what it is, that it's equal to this. Right? I would expect you to know this for a simply supported case. Okay? But I don't expect you to know anything further than that. I don't expect you to know the secant formula. I'll just make a note of this. Or how to derive the secant formula. but you should know how to use it. Or read a graph of the second formula. Okay, what did we go on to then? Flexure, I think, was next. I apologize if I'm out of, if I got the chronological order incorrect, but I think it's right. For flexure, you should know that the maximum axial loading in a beam, sigma max, is equal to the maximum bending moment times distance from the neutral axis divided by I. This is the maximum axial strength. Maximum axial stress in a beam. You should know that equation. Okay, the next thing we did was yield criteria. Okay. You should know how to find principal stresses. So that is, find eigenvectors and eigenvalues, or eigenvalues and eigenvectors, which gives you the direction. Okay, you should know Tresca's formula, the shear stress, maximum shear stress. Well, you should know that we had three yield criteria. You should know Tresca, the maximum shear stress theory, which said that the maximum shear stress is equal to the maximum principal stress minus the minimum principal stress divided by 2. Okay? And if you wanted to know if something had yielded, you compare that to yield stress on 2. And you should know, of course, the maximum principal stress is the first one, just comparing the principal stress to the yield stress. And the third, and almost the last topic, is von Mises. Now, I don't expect you to derive it or know how to derive it, but you should know how to use it. And you should be, if you need this equation, you'll be given it, so you don't need to remember this. But you should know how to use it and what stresses to put in here. These are principal stresses, remember, not just any stress. These are principal stresses. Okay, so you should know how to use it, not memorize it. Okay, and the last thing is to know your rotation matrix, R. Right, I expect you to remember this and to be able to use it. I think in every exam I have set, you've been required to use this. This is the rotation matrix. So you would be very foolish not to remember this, and also to remember that if you want to rotate a stress matrix, say sigma, if I want to rotate that, I take this matrix with a certain angle, multiply it by its transpose, and then multiply by the matrix itself, and this will give you the rotation. So if you take the original stress matrix, okay, and rotate it by theta, anti-clockwise, plus theta is anti-clockwise, then that will give you the stress matrix in rotated reference frame. Okay, so I'd expect you to know how to do this. Okay, that's all the topics that we covered, and they are only the equations that I wrote down that I told you need to know are equations that you need to know. Anything else, any other equation you need to know will be given to you in the exam question, and you should know how to use it, but not memorize it. Okay, as I've said already, the exam will consist of 2 parts. There's Part 1 is mechanics. Part 2 is materials, which I'll not say anything about here. There are 3 questions. There are, each question is worth 10 marks each, 10 marks. You need to complete all of them in order to get full marks. Okay, and as usual, 80% of the question, or 8 out of 10, should be easier, and 20% hard. So expect the last bit of the question to be challenging. Okay, so to give you some advice for preparation, as I have said, do tutorials, of course, okay, and past exams. Past exams, which ones did I teach? I taught this in 2009, 2010, and then I took a break, and I taught it again in 2015 and 2016. So those exam papers you'll find are a very similar format and of very similar difficulty to the exam that you are about to encounter. Okay, if you have further questions, feel free to send me an email. I will make myself available if people need to see me. If you do want to see me about past exam questions, you must have tried the question before you come and see me. I will not be answering questions for people who haven't tried. So make sure you bring your working to show me. It's also more efficient that way, and you'll get more out of it. Okay, well, thanks again for your attendance this semester. If I can leave you with one last thing, always draw a diagram. I didn't get to say this in the lectures, but you saw the way that I teach, the way that I communicate is through drawing as much as possible. And I think whenever you encounter a problem, try and draw a diagram. I think it's the best way for you and the best way to communicate with other people. Other than that, good luck in the exam, and I'll see you on Tuesday.